Today we will talk about iteration method for solving the large system of algebra equations. Okay, so iterative method for AX equals to B. Okay. Before we talk about Gauss elimination or LU decomposition, when the system is small size, but when you enlarge the dimension of such algebra equations, such as n by n, this n is large. For example, this n by n system for a matrix is like 10 to the fifth to 10 to the ninth square size. Then this system is pretty large, and using Gauss elimination or LU decomposition, you couldn't solve it. So we have to use this iterative method, this numerical treatment for solving the X. Okay, so we have this AX equals to B. This B is n by 1 vector, and B is known. The A is an n by n system, where the system is pretty large. The n is 10 to the fifth to 10 to the ninth. X is also very large, so X has the same dimension. Which is n by 1, the same as the B part. We couldn't use LU decomposition. And Gauss elimination is too expensive to solve because the order of the computational expense is n to the third for both LU decomposition and the Gauss elimination, right? N to the third. So you couldn't solve using this two method. You will use this iterative method. So often-wise, this A is sparse and large. So when I say sparse, means mostly are zeros in your matrices. And when this A is large, like n to the 10 to the fifth to 10 to the ninth, and also sparse, iterative method is very efficient. So we will first introduce one iterative method called the Jacobi iteration. So the method 1 is called the Jacobi iteration. And let's introduce what is the Jacobi iteration. Let's make an example, then I think things can be clear with the example. We have the system. You have the system which is a 3 by 3 system for the A. So 4x minus y plus z equals to 7. 4x minus 8y plus z equals to negative 21. Minus 2x plus y plus 5z equals to 50. So this is a small system, is a 3 by 3. You can also write as AX equals to B. So the A will be the coefficient. The X is your unknown, which is X, Y, Z here. The B will be whatever on the right side, 7, negative 21, 15, right? And you can input those coefficients, which is 4 minus 1, 1, 4 minus 8, 1, minus 2, 1, 5. So you can also translate this algebra equations into state space representation, which is AX equals to B. Okay. Then for the Jacobi iteration, what is the first step? So the first step of the Jacobi iteration is trying to isolate it u x, y, z. So isolate x, y, and z. How to isolate x, y, z from each algebraic equations. So the x, let's see, the x will be equals to, from this equation 1, will be y minus z plus 7 divided by 4. Okay. The y will be equals to, from the second equations, will be minus 4x minus z minus 21 divided by minus 8. This is your y, isolated y. The z will be equals to 2x minus y plus 15 divided by 5. So the first step of the Jacobi iteration is trying to isolate it x, y, z from each algebraic equations. So x from the isolated x from equation 1, isolated y from equation 2, and isolated z from equation 3.